Okay, sure. What have you done for this problem?
I did n is 1, and then from there I was able to limit the I forgot what you call it, the constant, like the GIF of the constant has to be between 0 to 2.
Okay, so let's write 1 minus 1, right? Plus lambda times GIF of lambda, right?
Right.
Then we can say what? Here we can say
Yeah,
2
that's
times this one plus this one times this one, right? Equal to this one. Then what?
yeah. Oh, I let lambda be k plus r, so it becomes 2k equals GIF of k plus r times k. And from the GIF of k plus r times k, you can make that k squared plus GIF kr. And then,
Which is greater than equal to k squared, right?
yeah,
So 2 is less than greater than equal to k, right?
yeah.
Okay, then what?
And then, I know k is 1 doesn't work.
So because k is less than or equal to 2, let's focus on integer part. It says lambda is greater than 0. So because lambda is greater than 0, we can say what about k? K can be what numbers?
0, 1, 2.
Yes. So let's consider first this. If k is 2, what can we conclude?
Is 2, you can conclude that it'll be 4 equals 4 plus in GIF of 2r. So GIF of 2r is 0.
Yeah, so 2r is greater than
2r
equal to 0, less than r less than equal to 0, less than 1/2, right? Let's consider second case. K is 1. Then what can we say?
k is 1, it'll be 2 equals 1 plus GIF of r, which means GIF of r is 1, which is contradiction since r has to be less than 1.
Exactly. What about third one? K is
K
what?
is 0.
0.
Becomes 0 equals 0 plus 0.
0 is equal to 0, right?
Yeah.
Okay, so we found two cases. It is 2 and something or 1 and something, right?
Yeah.
So then what?
I wasn't sure what to do next.
We can check N2, okay? To see, for example, to
Oh,
reject one of them, okay? So in this case, N is R, which R is from 0 to 1, right? And it's strictly greater than, sorry, N not, lambda, right?
okay. Yeah.
Lambda and R is strictly from 0 to 1, because if R is 0, then lambda is 0, right? In this case, lambda is 2 plus R, which R is from 0 to 1/2, right? So want to check N2 first on your own to see can you reject one of them, or want to do it together or on your own?
I can try on my own.
Okay, sure, try. Have you checked N2?
Yeah, I was able to reject K0 case.
Okay, so let's check. For N2, it will be 2 times 2 lambda is equal to 1 minus 2 negative 1 plus lambda times 2 lambda, right? First case is lambda r from 0 to 1, right? So in this case, it will be what? 2 times 2r, right? Equals negative 1. R times 2r, right?
Right.
Then what can we say? We should check 2 cases. R from 0 to 1 half, or R is from 1 half to 2, right? To 1, right?
Right.
In this case, left hand side will be what?
It'll be 0.
Right hand side?
Negative 1.
Yes, contradiction. What about second case?
2 equals negative 1 plus GF of 2R.
GIF of?
2R, which is...
No, not 2R. GIF of? Do you agree? This one is 1. So GIF of R, right? GIF of R will be what then?
3.
Is it possible?
No.
No. Okay, so we have only one case. And K is 2, right? Lambda is 2 plus R, which R is from 0 to 1 half, right? So 2 times 2 lambda is 4 plus 2R, right? Is equal to negative 1 plus 2 plus R times floor of 2 lambda is what?
It'll be 4.
Yes, it will be 4. So times 4, agreed? Now, if we check, we have what? 8 plus 1, 9 is equal to 8 plus 4R, right? So we can conclude floor of 4R is what?
1.
So what can we conclude about R?
1/4 less than or equal R less than 1.
Exactly. So R is N lambda is 2 plus R, which R is from 1/4 and 1 half, right? Now, like 2, we want to work on general N, okay? Let's work on general N. Want hint for this part or want to try on your own?
I can try.
Okay, sure. Try. Let me know if you want it.
Oh. Can you hint? I couldn't get it.
Okay, sure. So here we know that lambda is 2 plus r, right? So it will be 2n plus rn, agreed? Is equal to 1 minus n plus what? 2
2 plus r times
r times lambda n, which is what? 2n plus r. So first step, we should find this one is what? So how can we find this one is what?
Um,
Do you agree we can take 2n outside?
yeah.
It is 2n plus floor of Rn. So how can we find floor of Rn?
It's between n over 4 and n over 2.
Let me tell you this. Do you agree it's important that R is what over N, right? For example, suppose R is greater than equal S over N and S plus 1 over N, right?
Right.
Then can you tell me then Rn will be what? From S and S plus 1, agreed? You can first write this one, then this one, or this one. Understood?
Okay.
And we know, for example, R is less than 1/2, right?
Right.
So now we know S plus 1 is this one in general. S plus 1 in general is less than or equal n, right? Because the last one is R from n minus 1 over n less than 1, right?
Right.
We can also use this one to find a better bound, but we consider that R is less than 1 first, right? Okay, now can you tell me in this case then we can conclude floor of Rn is what?
Or Rn is S.
Exactly. So it will be what? 2 times 2n plus
2n
s,
plus
right?
S.
Is equal to 1 minus n plus what? Plus 2
4n.
plus r times 2n plus s, right?
Yeah.
Now let's simplify. We can say, okay, 2 times 2n, s also is integer. So we can say 2 times 2n
4n.
plus s, 4n plus a 2s plus floor of r times 2n plus s, right?
Right.
Is equal to what? 4n plus 2s plus n minus 1. Agreed? 4 and 4n will be cancelled. 2s will be cancelled. So we can conclude r times 2n plus s is equal to n minus 1, right? And we know r is from s over n to this one. So now let's consider this part. What can we say here?
Oh, r times 2n plus s is greater than equal n minus 1 less than n.
Greater than or equal n minus 1 less than n. And also we know r is from s over n to this one. Want to try rest on your own or one more hint?
Is it for the next step, do you divide by 2n plus s, or is it?
We can divide by 2n plus s. Also, we can use this one. So let's consider. We know that r is from s over n and s plus 1 over n, right? And as you said, we can say r is less than n over 2n plus s, right? And greater than equal n minus 1 over 2n plus s, right?
Right.
So here you can use, for example, these two inequalities to see what can we reach, right? And we know s plus 1 is less than n, right? Less than or equal n. And you have these things. And you know for different ends, you can reach these things, right? For different ends, you should find corresponding s, right? And then you have these two inequalities, okay? So we said if r is from this to this, then we have these two inequalities. So, for example, one thing, do you agree we can say n minus 1 over 2n plus s is less than what? Do you agree this one is less than this one? Because
That's both one over n. Okay.
exactly. So let's see what can we reach here. N squared minus n is less than 2ns plus s squared plus 2n plus s, right?
Right.
Okay, and we know s is at most n minus 1, right? Okay, so for example, we can consider these things to find, for example, approach for n. If you think it's hard, we've checked for n2, right? We could solve it for n2. We
Right.
can check for n3, n4 to see how we can use them to find r and then generalize it, okay?
Okay.
One more hint or that's enough?
I think that's it.
Okay, sure. 1/10?
I'll keep trying.
Okay, sure.
Yeah, can you keep
Okay, sure. So here, let me work on this again. Copy, paste it here. We found that lambda is 2 plus r, right? Agree?
Yeah.
Okay, so here, for example, we can say 2 times floor of this is 1 minus n plus 2 times lambda n plus r times lambda n, right?
Right.
Do you agree it is equal to 1 minus n plus 2 times lambda n plus floor of r times lambda n? Agree this?
Yes.
So do you agree we can cancel these two things? Agreed?
Yeah. Yeah.
Okay, now we can say r times floor of lambda n is what?
Um. N-1.
Yes. So we can say that r times 2n plus Rn is equal to n minus 1, right? Agreed? Agreed or want me to explain?
Agreed.
Okay. Now we can say R times 2n plus Rn is from what to what?
It's from n minus 1 to n.
N minus 1 to n. So, for example, let's check small cases to see is it correct or not. So, for n2, we can conclude what? 1 is less than or equal
1
r times what? 4
plus
plus
r.
2r, right? Less
sure.
than 2. So, what can we say about this?
Uh, it's
We've considered two cases for this, right? So in first case, we knew that r was, let's consider n1 first. For n1, it will be what? 0 less than or equal r times what?
2 plus r.
Less than 1, right? So here, what can we say?
It's between 0 and 1/2.
If r is greater than 1/2, what happened?
R is between 0 and 1/2.
Okay, so this one is at least 2, right?
Right.
So that's the reason we know that r times 2 plus r is at least 2r. So we can say it's less than 1, so r is less than 1/2, right?
Yeah.
Now, if you want to use similar thing, 4r is less than 2. If you use that approach, this. But for this one, we can say what? Do you agree we can say r times 4 plus 2r is less than 2, right? Also, do you agree here we could say r times 2 plus r less than 1? No. We cannot say that. Because this one is floor, not ceiling, right?
Oh, wait, why can we say r times 4 plus 2r
Here
is
we
less than
cannot
2?
say. We can say 3 plus 2r, right? If you apply this, what can we conclude?
3r plus 2r squared less than 2.
2r squared plus 3r minus 2 less than 0, right?
Right.
So what are the
2r
roots?
r is 1/2 and negative 2.
Okay, so it's 2r or 2r squared for 3r negative 2 plus 1 negative plus 2 minus 1, right?
Yeah.
Less than 0. So 1/2 and negative 2, right? Because it's less than that. Again, we reach r is less than 1/2, right?
Right.
Same thing. But if you use first one, as we said before, if you say, okay, r is 1/2, so if r is less than 1/2, then we can say 4 plus 2r, floor of this is what?
4.
So for r is less than 2, r is less than 1/2, right? But we
Right.
considered n2 and we said r is less than 1/4, or we considered n3. We proved that r is greater than equal 1/4, right? For
Yeah.
that part. So if we use this part, we can say what? R times 4 plus 2r is greater than equal 1, right? So we can say 2r squared plus 4r minus 1 greater than equal 0, right? Okay, then what can we say? The roots are what?
The roots are
Right?
Mhm.
Negative 2 plus minus what?
root 6.
So because we know it's positive, negative 2 minus root 6, negative 2. So r is greater than equal negative root 6 minus 2, right? Okay, now if you want to use similar thing, let's use for general n, okay? Because we know it should be correct for all n, right?
Right.
So what can we say? For example, one thing that we can say is that r times 2n plus rn is greater than equal n minus 1, right? So r squared n plus r times 2n plus 1 minus n greater than equal 0, right?
Right.
Okay, so what are the roots of r? Negative 2n plus minus square root of
4n squared
minus
minus plus 4n squared
times this, right?
over
Over 2n, right?
Right.
Negative 1 plus minus square root of 4n squared, 8n squared, right? 8n squared minus what?
4n.
4n over 2n, right?
Right.
So it will be negative 1 plus minus what?
Square root of
2
2n
minus
minus 1 over n. Oh, 2 over 1 minus
1 over n, right?
1 over n.
So we have two roots. It should be greater than equal 0, so it should be negative. It's not important. This one is important, right? And this one is negative 1 plus 2 minus 1 over n, right? So we can say r is always greater than equal negative 1 plus 2 root 2 minus this one, right? Okay, so what can we say next step? So do you agree when n goes to infinity, it will be root 2 minus 1? Agreed?
Yes.
Okay, let's consider this part. We can say what? R times 2n plus Rn minus 1, right? Is less than n, agreed?
Right.
Then we can say what? R squared n plus R times 2n minus R minus n less than 0, right?
Right.
So the roots are what? Again, negative 2n plus minus square root of b squared 4n squared minus what? Oh, sorry. R is not constant. We should consider R times 2n minus 1, right? Less than 0. So R is what? Negative 2n minus 1, agreed? Plus minus 2n minus 1 squared minus plus 4n squared, agreed? Over what? Over 2n, right? So it will be negative 1 plus 1 over 2n plus minus, right? It will be what? 4n squared over 4n squared is 1, right?
Right.
And 2n minus 1 over 2n whole squared, right? Okay, so we can say r is, because r is less than this, so r should be less than larger root, right?
Right.
So r is less than negative 1 plus 1 over 2n plus minus square root of 1 plus 2n minus 1 over 2n squared, right?
Right.
And do you agree also r is greater than equal negative 1 plus square root of 2 minus 1 over n? When n goes to infinity, what happens to left hand side? Left hand side approaches to what?
Square root of 2 minus 1.
What about right hand side? This one, because r is smaller than this, r is smaller than greatest one, right? Because if it is negative, then r will be negative, right? Understood why we should consider plus sign here? Or 1 meter?
Yeah.
Okay. So this one, if n goes to infinity, it will be what?
-1 plus. Oh, square root of 2.
Do you agree? So because when n goes to infinity, it is between two numbers. That limit of both of them is √2 minus 1. So we can conclude r is what?
√2 minus 1.
Yeah, so lambda is what?
Is 2 plus √2 minus 1 plus √2.
2 plus √2 minus 1, which is 1 plus √2, right? Okay. Understood completely. Let's check also our solution. 21 plus √2. Okay. It doesn't have solution to check. Do we have any, for example, easier solution or not? But look, we don't need to check all these things. We can only start from here. Okay, we can say that when we consider this r times lambda in this equation, and then you consider, okay, r is 2 plus something and lambda is 2 plus r, then you should apply this inequality. Understood, or want me to explain more?
Oh wait, after you get and lambda is 2 plus something, 2 plus r, what's next?
Okay, so let me tell you important parts that we did. By a small example, we understood that r is 2 plus lambda is 2 plus r, right?
Yes.
And because r is 2 plus lambda is 2 plus r, this one, then do you agree we can conclude this one, or want me to explain?
Yes, 2 plus r.
First step is this,
Yes,
second step is this. Agreed this?
Oh.
Okay. Then do you agree we can replace this where we reach this, right?
Right.
Then do you agree we can conclude this? Agreed?
Yes.
Then this one was 4. We don't need these things. This one is 4 again, right? Agreed? You should solve each of them. What? Which part? 4 or 3?
1, 3.
How we reach 3 or 2?
Oh no, just looking through. Oh, okay. I think it's a
Okay, 1, 2, 3, 4 are okay?
yeah.
Okay, now for 4, we have two inequalities, right?
Right.
Do you remember I told you one of the most useful things is to split the number into integer part and fractional part, right? And we did exactly the same thing here, and I think all problems that we solved about integer part or floor in AIME, PMO, in all of them we should use this idea, right? Okay, now for this one, I used what? I used that when you have x, do you agree it is less than, or let me tell you, it is greater than x minus 1? And do you agree it is less than or equal x? Agreed this? Okay, so I use this part. I said, okay, this one is greater than this minus 1 times r, because this one is greater than that, so that part is less than n also, right?
Right. Sure.
And then for this part, I found the roots, and I say r should be greater than this plus this, right? Okay, it is the fifth. Now, if we use this part, we know that floor of x is less than or equal x, so this one is less than or equal this, so times r is again greater than or equal this. Agreed this?
Yes.
So then I saw this, we consider this one as a quadratic equation inequality, and we found the roots, and then we proved sixth one. That r is greater than or equal this, right? Then we said, okay, so from 5 and 6, r is from 6, r is this, from 5, r is less than this, right? Now, if n goes to infinity, this one will be √2 minus 1, right? This one also is √2 minus 1. In calculus, we have this formula that when we have r is between something and there, for example, limit when n goes to infinity, we have Same thing for both sides. Also, if r will be root 2 minus 1 equals their limit, right?
Right.
And lambda is 2 plus r, which is 1 plus root 2. Understood completely and 7-1.
Understood. Oh, could you go up a bit to number 5 again? Just
Okay.
wanted to.
Want me to explain 5 or want to review on your own?
For 5, it was just, I was wondering why we did like r is less than negative 1 plus, like, why instead of making it r is greater than the other
Do you
side?
agree if you consider this equation, it opens up, right, in terms of r?
Right.
And we said it is less
Oh,
than
okay.
0,
This
so
makes
it should be
great
between
sense.
two roots. One root is negative, it's not important because we know r is at least 0. This root is important. R should be less than this, right?
Right.
Okay. Any question about this?
No, I think it's okay.
Okay, I can say